సారీ, యాక్చువల్లీ నేను ఇది రికార్డ్ చేస్తుంటే మధ్యలో కాల్ వచ్చింది, సో మళ్ళీ డిస్టర్బ్ అయిపోయింది. చూద్దాం. Now once again I am explaining you this one. Hamida gave me this problem. Lambda is equal to 3, 5, 10 are the characteristic roots, or you can say eigenvalues of this matrix. Sir, how to find basis for eigenspace? Sir, whether it is diagonalizable or not. Sir, how to find eigenvectors? All these are same procedure. Suppose if you compare with these two with this one, diagonalizable matrix means 100%, eigenvectors means 97%, basis for eigenspace is 99%, or you can say 98%. That is the difference, right? Now see, for any matrix A, whether it is 2 by 2 or 3 by 3, you know how to find eigenvalues, you know how to find characteristic equation. Each step is very very important, right? Please do not skip the step, write the steps clearly. Now you know, after this is a given matrix, you know how to find a characteristic roots, or you can say characteristic equation or eigenvalues. After getting the eigenvalues, now I am going to find eigenvector corresponding to first eigenvalue. First eigenvalue is 3. Now I am taking 3. A minus lambda into x is equal to 0. A minus lambda means 3. 3i into x is equal to 0. A means I have to write A matrix minus 3 into unit matrix, whole thing into x is equal to 0. Now directly I am simplifying. So you know how to write the steps, right? Please do not skip the steps. Once I am requesting you. Now 3 minus 2 0, 2 minus 2 6 0, 5 8 0. Now if you have to write here A multiplied 3 inside and then subtracting, you will get this matrix. What is x? X1, x2, x3. Why 3 variables are? Because it is of order 3 by 3. Now if it is of order 2 by 2, we have to take x1, x2, right? Now see, if you multiply these two matrices and if you equate it to 0, you will get 3 equations. Now we have to solve those 3 equations by our standard procedure. Now we'll get x1, x2, x3 values. Those x1, x2, x3 values is called an eigenvector corresponding to the eigenvalue lambda is equal to 3. That is clear? Now instead of multiplying and solving those equations, now there is a simple method. Reduce this method matrix to echelon form. See, first of all I am interchanging these rows. Why I am interchanging these rows? Because for my easy calculations. And then divide the first row by minus 2. I got this one, right? Then I am changing R2 changes to R2 minus 3R1. First row is unaltered. 3 minus 3 is 0. Minus 2 minus of minus 9 plus 9. Minus 2 plus 9 is 7. 0. Now R3 also. R3 changes to R3 minus 5R1. 5 minus 5 is 0. Now 8 minus of minus 15. 15 plus 8 means 23. Now 0 minus 0. Again principal diagonal, I have to make this one as 0, 9. Right. Now what I am doing here, R2 changes to R2 by 7 I am doing for easy calculation. See, now first one is 1 minus 3 0 0 1 0 0 23 0, right? I got this one into x1 x2 x3 is equal to 0 0 0. Principal diagonal, we have to make this one 0. R3 changes to R3 minus 23 R2. 1 minus 3 0 0 1 0 0, 23 minus 23 0. Now x1 x2 x3 is equal to 0 0 0. Now multiply these two matrices, equate it to 0. How many equations you will get? Now 1 into x1 is x1, minus 3 into x is minus 3x2, 0 into x3 is 0, is equal to 0. Similarly, by using second row, 0 into x1 is 0, 1 into x2 is x2, 0 into x3 is 0. Now x2 is equal to 0, right? Now see, similarly third one. Okay, now we got x1 minus 3 x2 is equal to 0, x2 is equal to 0. See here, x3 is independent. There is no x3 in our equation, right? Now you can solve this equation. X2 is already 0. You can substitute here. You will get x1 is also 0. X3 is independent. You can take it as k. Therefore, x is equal to x1, x2, x3 is equal to, what is x1 value? 0. x2 value? 0. x3, there is no x3, no independent, that means k. Now this is called eigenvector corresponding to eigenvalue 3, right? Similarly, in the same fashion, we have to find eigenvector corresponding to eigenvalue 5. Instead of 3, we have to write 5. We have to find x1, x2, x3. Now, to find this one, there are different process are there, different procedure are there. You can opt any other procedure. Now we got x, right? This is 1. Now similarly for 10 also you will get another eigenvector. Now find the eigenvector means clearly we have to write x1, x2, x3 is equal to 0, 0, xk is the eigenvector corresponding to eigenvalue 3. Similarly you will get other one. Similarly you will get other one for 10, right? Now see, if you combine, that means if you collection of these eigenvectors in a row wise, okay, and also you will get second eigenvector, third eigenvector corresponding to lambda is equal to 5, corresponding to lambda is equal to 10, no, right? Now this is called basis for eigenspace. One extra step, that's it. If it is 97%, then 98% is basis for eigenspace. Now we have to collect eigenvectors in a row wise is called an eigenbasis, right? Sir, how to find whether A is diagonalizable? See, this is for this, show that if the question is show that if A is diagonalizable, then we have to write the same procedure, right? Now we got CH roots, or you can say eigenvalues. What are the eigenvalues? 3, 5, 10. No? Therefore, D is equal to 3, 0, 0, 0, 5, 0, 0, 0, 10. This is the diagonal matrix. Now, sir, what is P star? P star means the first eigenvector. What is the first eigenvector we got? 0, 0, k, no? That column we have to write, column wise, 0, 0, k. Suppose, here I am writing, I am telling suppose, if the second eigenvector is say 1, 2, 3, write 1, 2, 3. If the third eigenvector corresponding to lambda is equal to 10 is minus 1, 1, 1. Assume that, here this random values I am writing. Now this first column, second column, third column. Order is not important, right? Now that is called invertible matrix P. Okay. Then after writing these two, we have to find A into P. We know A matrix, we know P matrix. Multiply those two, you will get something. Sir, ఇక్కడ k ఉంది కదా sir, what happened? You can take k is equal to 1 or k is equal to 2 or k is equal to 3, your wish. Next we can find P into D. We know P matrix, we know D matrix. Multiply these two. If they are equal, A is diagonalizable, otherwise not. Remember one thing, if the characteristic roots, or you can say eigenvalues, are distinct, then A is always diagonalizable. A is always diagonalizable, remember. That means you will get AP is equal to PD, right? That is the procedure. Remember what is the definition of diagonalizable? A is equal to PD P inverse, okay, or P inverse DP. The next topic is, now I said diagonalizable is over now, right? Now how to find P and D? P and D means first of all we have to find characteristic values or eigenvalues. Those values you have to write in principal diagonal elements, rest of the elements are zeros, that is called D. Now how to find P means the eigenvectors you have to write in column wise, that is called P, right? Show that a matrix is diagonalizable means we have to find characteristic roots eigenvalues, eigenvectors, then write D, then write P matrix, find the product of the matrix A and P, and then find the product of the matrix P and T. If they are equal, then we can say that the given matrix is diagonalizable. Okay, this is Hamida problem. Okay, leave it. Next, now eigenvalues and linear transformations. Now see, this is your linear transformations topic. Linear topic, V and W are two vector spaces, right? A mapping T from V to W is said to be a linear transformation if T of U plus V is equal to T of U plus T of V, and T into C of U is equal to C into T of U, where U and V are any two vectors in V, right? Now, if those two conditions are satisfied, then the mapping is said to be a linear transformation. See, this is the first vector space, this is second vector space, this is called domain, this is called codomain. Now T is a mapping, we know that. Now suppose if X, I am writing clearly, see, X is an element in V, then its image of X is denoted by T of X. T of X is in W simply, right? If U is an element in V, then its image is T of U. T of U belongs to W. Suppose if V belongs to capital V, this is small v, this is capital V, where capital V is a vector space, then T of V belongs to W, right? Images are in codomain, here the codomain is W, right? When do you say that a function is a linear transformation? If these two conditions are satisfied, and means LHS is equal to RHS, then it is said to be a linear transformation. Okay. Now here, how to find the matrix for T relative to the basis? Matrix for T relative to the basis, right? This is important. It's very easy. See, this is V, this is W, no? This is a mapping, okay? For V, there is a basis, say you take B. I am taking only B1, B2, two elements, right? For simplicity. Now I am taking C. Here C1, C2 is a basis. It is also a basis for V, okay? This C is a basis for W, right? Now you have to read the problem clearly. Which one is basis for which one? Now here B is a basis for V and C is a basis for W. Okay. Now I am choosing a vector in V. X is any vector in V. Now if X is equal to, now I am using R1 into B1, R2 into B2, because there are two elements I am taking, that's for two scalars. Now these scalars R1 comma R2 are called coordinates, right? Find the coordinates of a basis, and then first unit topic, right? First unit, find the coordinate means if X is a vector in V, if X is equal to I am using scalars R1, no? R1 into B1 plus R2 into B2. Solve this equation. We have to find those scalars R1 and R2. Those scalars are called coordinates of the vector X relative to the basis B. Now what is basis here? This one, no? Therefore those coordinates can be written as XB. XB is equal to what? R1 comma R2. This is the coordinates of this vector relative to the basis B. Okay, got it? Next page number, this one 8, 9, no? I have to wait, please wait for 1 minute. Now we know that VW transformation B is equal to B1 B2 basis, C is equal to C1 C2 basis for this one. Okay, if X is an element in V, then its image is denoted by T of X, which is in W, right? Now see here, if X can be written as some R1 into B1 plus R2 into B2, no? Here R1 comma R2 are called coordinates, right? Therefore xb is equal to R1 R2. The scalar values are called the coordinates of the vector relative to the basis B. Then in this case, what is T of X? T of X is an element, or you can say it's a vector in W. What is the basis here? C is equal to C1 C2. Therefore T of X is equal to some scalars I am using, d1 into C1 plus d2 into C2. It is a linear combination in the elements of basis, right? Now the coordinate, the scalars d1 d2 are called what? Coordinates. Now see, the coordinates of the vector, this vector is in W, no, relative to the basis. What is the basis here? C is equal to d1 d2, right? There is a difference between these two, no? Here X is a vector in the domain, right? Now R1 and R2 are the scalars relative to the basis. These scalars are also called coordinates, which is a topic, this was a topic in our unit 3, right? Similarly, T of X is a vector in W and the basis is C. Now the scalars are d1 and d2. These are called coordinates, right? Now therefore T of X, that means the relative, the basis for T of X, the coordinates for T of X relative to the basis C is d1 d2. Got it? Now see, if you collect these scalars, this is a matrix, right? Simply it is a matrix relative to the basis B. We'll see one example. Simply we have to collect the coefficients of the vectors in the codomain, right? See, now see, first one I am example, I am taking this one. Suppose b1 b2 is a basis for V and c1 c2 c3, there are three vectors, is a basis for W. Let T from is a linear transformation with the property that it is clearly given, right? Find the matrix M for T relative to basis B and C. Clearly concentrate here. What is given? T from V to W is a linear transformation. B is equal to B1 B2 is a basis for V. Next C is equal to C1 C2 C3 is a basis for W, right? VW T X T of X. Okay, now clearly given that T of B1 is equal to 3E1 minus 2E2 plus 5E3. T of B2 is equal to 4E1 plus 7E2 minus E3, right? Now see, this is T of B1, X is in V, T of X is in W. Remember, B1 is a basis for V. Basis for V means B1 B2 is subset of V, no? B1 is an element in V, no? If B1 is an element in V, then its image is in W. Now similarly X is in V, T of X is in W, right? If B1 is an element in V, T of B1 is in W. Now T of B1 is given. What are E1, E2, E3? These are the basis for W, right? I told you here T of X is in element in W. Now C1, C2 is a basis. This linear combination d1 and d2 are scalars. Those scalars are called coordinates. Now we have to collect those coordinates. Simple. See this one. Therefore, the coordinates of T of B1, right? With respect to basis C, T of B1 C is equal to, what are the coordinates? Simply collect the coefficient, 3 minus 2 5. These are the coordinates now. Similarly, the coordinates of B2, T of B2, because T of B2 is an element in W with respect to the basis C. Write the coefficient 4, 7 and minus 1. These are the coefficients, right? Collect these coefficients in a matrix, row column wise, 3 minus 2 5 4 7 minus 1. This is the matrix now. This matrix is called a matrix relative to the basis B, right? What we have to do, we have to concentrate on the image of an element of V. B1 is an element of V. Its image is T of B1. That T of B1 we are writing as the linear combinations of elements in the basis for W. These scalars are called coordinates. Now we have to write those coordinates in column wise. That matrix is called matrix relative to the basis. Matrix for T relative to the basis. Okay. Now see, this is an example. Please refer the textbook. And some more examples are there. This diagonal matrix representation, this theorem is there in your textbook, I think so. This is important. This is a notebook. See exercise. The first exercise I am going to teach you. First problem. See. Now, if B1 is B is equal to B1, B2, B3 and D is equal to D1, D2, be the basis for vector spaces V and W. T from V to W is a linear transformation with the property. Find the matrix for T relative to the basis B and D. First of all, I am writing the given data. What is the given data in proper order? V and W are two vector spaces, right? T from V to W is a linear transformation. B is equal to B1, B2, B3 is a basis for T. Sorry, basis for V. Now next D is equal to, what is given? D1, D2 is a basis for W. Got it? Now and also given data is T of B1 is equal to 3D1 minus 5D2. T of B2 is equal to minus D1 plus 6D2. T of B3 is equal to 4D2. Right? What is our aim? Our aim is to find the matrix for T. Right? Okay. Now see here. First one is V, second one is W. What is B? B is a basis. Basis means it is a subset of V. Now D1, D2. This D is a basis for W. Okay. There is a transformation. Now B1 you see. Look at B1. B1 is an element in V. Right? Then its image is T of B1 belongs to W. Right? This is the concept, no? Image of B1 is denoted by T of B1 which belongs to W, codomain. Now see, T of B1 is a vector in W1. Now T of B1 ఎట్లా ఎక్స్ప్రెస్ చేశాడు? ఇట్స్ ఏ లీనియర్ కాంబినేషన్ ఆఫ్ ఎలిమెంట్స్ ఆఫ్ basis C and sorry D is a basis, no? D1 and D2 basis for W. Now T of B1 is in W and T of B1 is expressed as ఎలా ఇచ్చాడు? 3D1 minus 5D2. It is a linear combination of the elements of D which is a basis for W. Then those, what we have to collect? Coordinates. What are the coordinates? Coordinates of T of B1 with respect to the basis D is equal to what? 3 comma minus 5 scalars. Similarly, T of B2 is in W because B2 is an element in V. Its image is in W. Now T of B2 is a vector in W which is given as minus D1 plus 6 D2. Now, therefore, the coordinates of T of B2 with respect to the basis D are coefficients minus 1 comma 6. Similarly, T of B3 is an element in W. Now, T of B3 is given as 4D2, right? Now, therefore, the coordinates of T of B3, because it is a vector, no? With respect to the basis D is equal to, write down the coefficients. What is the coefficient here? 4. Only 1. That means the first one is 0. 0 into D1, no? 0 into D1 plus 4 into D2. 0 comma 4. Simply, therefore, matrix for T is equal to, write in column wise these coordinates 3 minus 5. Next, minus 1, 6, 0, 4. This is the answer. Right? The matrix for T related to the basis B and T is this one. Simply, you have to collect the coordinates. Those coordinates we have to write in column wise. Okay. This is one problem, one type of problem. Next one. All these are similar. See, third one I am doing. What is third one? Read the question. I am writing directly. V and R cube. R cube is a vector space and V is also a vector space. T from R cube to V is a linear transformation, right? And E is equal to E1, E2, E3, basis for R cube. Okay. Next, B is equal to B1, B2, B3, basis for V, right? Next, clearly given as T of x1, x2, x3 is equal to x3 minus x2 into b1 minus x1 plus x2 into b2. x2, no, sorry, this is, wait, I can't see this properly. x3. Next, plus x1 minus x2 into b1. Find the matrix. Set out the given data. Here the first set is R cube, second set is V, T is a linear transformation. Now this is E. E is a basis for R cube. B is a basis for V. Okay. Basis means first of all it must be subset, no? Right? Now what are E1, E2, E3? Remember E1, E2, E3. If it is cube, E1 is always equal to 1, 0, 0. E2 is equal to 0, 1, 0. E3 is equal to 0, 0, 1. Sorry, if it is power 4, then how to write? E1 is equal to 1, 0, 0. Another 0 you will get. E2 is equal to 0, 1, 0, 0. E3 is equal to 0, 0, 1, 0. And again you will get E4. 0, 0, 0, 1. Right? That is 4 tuple. Now, see, E1 is an element in domain. Its image is T of E1. T of E1 belongs to V, no, here from this diagram. E1 is an element in R cube. Then T of E1 is the image of E1 which is in V, codomain. See, what is E1? 1, 0, 0. Now, T of 1, 0, 0 belongs to V, codomain. Now t of 1 comma 0 comma 0, which is defined as, see what I am getting here, x3 minus x2, 0 minus 0 into b1 minus 1 minus 0 into b2 plus 1 minus 0 into, what is that last one, b3, sorry, this is b3. Simplify this one, t of 1 0 0 is equal to 0 into b1 minus 1 into b2 plus 1 into b3. Now see here, analyze this one. What is t of 1 0 0? T of 1 0 0 element in V. It is a linear combination in the elements of basis for V codomain. Now these are called coordinates. Write those coordinates. Now the coordinates of this element, it is a vector in V, with respect to this basis B is equal to 0 minus 1 1, right? This is nothing but t of E1 with respect to B, 0 minus 1 1. Okay, similarly we can find t of E2 with respect to B. T of E2 means 0 1 0. That means here what you will get here, t of E2 I am writing over here, t of E2 is equal to 0 minus 1 minus b1 minus x1 plus x3 ante 0 into b2, x1 minus x2 ante minus 1 into b3. Now what are the vectors here, minus 1 0 minus 1. T of E3, it is a vector in V with relative to the basis B, means collection of the coordinates. T of E3, E3 means 0 0 1, no? Here x1 is 0, x2 is 0, x3 is 1. Substitute over here, x3 minus x2 ante what I am getting, b1, x1 plus x3 minus b2. Next x1 minus x2 ante 0, 0 minus 0 is 0, b3. Coordinates are 1 minus 1 0, 1 minus 1 0. Now what are these? These are the coordinates of this vector relative to the basis B, this notation. Now if you collect these vectors in column wise, that is called matrix for T. First one is 0 minus 1 1, second one is minus 1 0 minus 1, third one is, this is called matrix for T related to the basis E and B. Please go through these problems.